Welcome to 1.5, page 4. We've talked about f of g, so we should just be ready to jump into this. Again, we're in the right small situation here. We're to find, it looks like just two parts, a and b. We're not going to use graphing calculator. However, you're welcome to do that. But we have to find f of g, g of f, and the domain, so we really have three things to do here. So a, f of g. Well, that is f of x cubed minus 1, because that's what g of x is. Remember, f of g means f of g of x, and I really like thinking of it that way. It's very descriptive of what we do. We're going to put g of x into f. F is a factory that takes the third root of the thing we put in, x cubed minus 1, and adds 1 to it. It puts the thing right there, and we get third root of x cubed, and that third root, love odd roots. We don't have any issues on odd roots with negatives, so it is just plain old x. Find f of g, g of f, and the domain of f of g. So let's go on with g of f. B, we want g of third root of x plus 1, and this has a really familiar feel to it, like we just did a problem very similar to this back on the earlier part of this assignment. So anyway, g is a factory that takes things, no matter how ugly they are, third root x plus 1, cubes them, subtracts 1, and we get third roots cancel. We get 1, we get x plus 1, x plus 1 minus 1, we get x. And this is that whole inverse function again. We see that f and g, they go through a process. F goes through all the trouble to turn g into this, or turn x into this, and then we put it in g, and we just get back to the original x that we started with. And our domain of f of g, domain of f of g of x, we have to survive through g. Well, any number I put in here survives through g. And then we have to make sure that we're good for f of g. Oh, any number I put in here is good. Our domain's all reals. Oh, I like it when that happens. Okay. F of g is f of square root of x. And f is a factory that takes the square root of the thing, so that actually equals f, not f, equals big square root of little square root of x. And here's where we might want to think of this as x to the 1/2 right here, to the 1/2 again, square roots 1/2, that is x to the 1/4. Just like x to the second times x to the third is x times x times x times x times, I guess it's not just like that. That would be x to the 5th, but let's see, I'll put it right here. If I have x squared to the 3rd, how do I handle that? That's xx, xx, xx. That's x to the 6th. 3 groups of 2 x's. So we multiply those exponents when it's an exponent to an exponent. And we could write that as the 4th root of x. So our domain, hey, x can't be negative. And our domain of g, the function we have to survive through first, x can't be negative. So our domain is x has to be, I guess that's part C. Part C, the domain of f of g of x is x has to be greater than or equal to 0. That, of course, could be written as 0 including 0 to infinity. Part B, g of f. Well, g of f of x is going to end up being the same thing in this instance. I think that's pretty clear. Okay, 60. A. Let's do this in the right order this time. F of g of x is f of negative x squared plus 4. And f is a factory that takes things and puts them inside of absolute values. And that is it. B. G is a factory. G of f is g of f. F is absolute value of x. G is a factory that takes things, puts them right there, and adds 1. And if we think about that for a moment, we can simplify that, because x squared is going to become a positive value unless it's 0. And the opposite of a positive value is just negative. So this is actually just negative x squared plus 1. The squared, obviously squares a number, but it makes a number non-negative. That's exactly what absolute value does. So the absolute value is not necessary there. And C, f of g of x is domain. I can put anything I want in here for g. How about f of g? Oh, I can square any number I want, take the opposite of any number I want, add 4 to any number I want, take the absolute value of any number I want. Now, how would we be able to use our calculator to determine, the domain? We'd go ahead and just graph this thing. We'd see that graph lives forever. So domain is all reals. But at 66, I can tell we're going to have some domain issues down the road. So let's go f of g of x. F of g of x is f of negative x. F is a factory that puts 6's on top of 3 times the thing minus 5, and we get 6 over negative 3x minus 5. Now, I'm going to tell you this. There's a very good possibility that the solution guide won't have that. We know that 3 over negative 4 is the same as negative 3 on positive 4. It's very possible, I don't know for sure, that the back of the book multiplies this by negative 1 on negative 1, or our solution guide. It's very possible this is negative 6 on 3x plus 5. Either of those would be fine. B. G of 6 on 3x minus 5. G is a factory that takes the opposite of the mess we put into it, and we get negative 6 on 3x minus 5. Close, but a little bit different. Okay. And now we want to see the domain of this guy. Well, I can see clearly that x cannot equal subtract 5 divide 3. But we also had to survive the trip through g, the first factory we went in, f of g. But any number at all survives this. But if I do put negative 5/3 in, that ends up presenting trouble further down the road. Would we really have to put the domain here? No, it's implied right here that x cannot be negative. Right here, that x cannot be negative 5/3. Okay, kind of a fun one here. This one causes some confusion, but I think if you pay attention, it's going to make some sense. F minus g of 1, that's f of 1 minus g of 1. And f minus g of 1, well, f of 1 is the height of graph f. Here's f. I think you can see it. Here's g. This is the height of f at 1. The height of f at 1 is 2. The height of g at 1 is 3. 2 minus 3 is negative 1. And you say, well, why does that cause problems? Not so certain. These ones are a little bit sneakier in 70, but fg of 4 is f of 4 times g of 4. That's the height of f at 4. That's where we want our thinking to be. We see f of g of, that's a height on a graph. If they give us the graph, it's really important we think of it that way. The height of f at 4 is 4. The height of g at 4 is 0. We get 0. Now, f of g of 1. We're going to put 1 into g. This is the height of graph g at 1. Oh, well, that's 3. And then I turn around and I put 3 into f. That's the height of graph f at 3. Oh, that's 2. So I just want to tell you, this might look easy for me. It is not always easy for students, so I'm really trying to open up our lines of communication. If you're struggling with this, don't be embarrassed that, hey, you made it look easy, I still don't get it. We'll talk about that. So here I want g of f of 3. The height of f at 3 is 2. F of 3 is 2. Now I want to find the height of g at 2. At 2, the height is 2. Okay, there is an 11.5-minute video. Probably going to maybe have some questions on domains up here, 55 through 65. Stay in touch with me. Let me know how we can clear this up.